Welcome to Digital Learning Platform of Sri Guru Sudhindra College, Department of Computer Application BCA, subject Microprocessor 8085, and the topic Rotate Instructions. Rotate instructions are very useful instructions in microprocessor. There are two kinds of rotate operations here. One is left rotation and one more right rotation. At first, let us focus on left, then we can go through right. Both in left rotation and right rotation, we have two individual instructions. In left rotate, we have two separate instructions, RLC, RAL, and in right rotate, we have got two more instructions, RAR and RRC. Let us go through the instructions one by one. At first, let us focus on left rotate operation, and the instruction what we are discussing is RLC, rotate accumulator towards left side by one position. To understand this, let us take one example. The example number 78. Number 78 is in decimal format. This decimal format has to be converted in binary. When you convert 78 in binary, we'll get this pattern 01001110. This is the binary equivalent of number 78. So what is the task? The task is rotating this particular number towards left side. Rotating the number towards left side by one position. The instruction RLC, what it does is, it is going to rotate. Rotation is nothing but it is going to move the bits present in this particular register towards left side by one position. RLC, rotate accumulator towards left. The content, the number 78 in binary format, it is stored in accumulator. So the content of accumulator, we are shifting it towards left side by one position. On screen, you can find at the left hand side, there is a special block called CY. CY stands for carry. Now currently in the right hand side, you are finding the register. There is the special register called accumulator. In this accumulator, we have got set of contents 01001110. This particular content, we are shifting it towards left side by one position. Let us see what happens when you shift it towards left side by one position. See, on screen you are finding the number is shifted towards left side by one position. One bit has moved out and that bit has stored in a place called carry. Now what happens to the existing number? Once all the bits are shifted towards left side, automatically at the right side there is a vacant space. Now this vacant space has to be filled up. What has to be done? Now here, as and when you apply RLC instruction, the content of register, it is going to move out, and at the same time the number whichever has come out from the register, from the accumulator, the same bit is going to store in this right block. See, we are performing left operation. As and when you rotate the number, as and when you shift the number, as and when you move the number towards left side, automatically at right hand side the space will generate. So in this particular space the number has to be stored. So we call it as rotate instruction. The number whichever has moved out towards the left side, same number will come and store it in right position. This is the first instruction, RLC, rotate accumulator towards left. Now the second instruction, RAL, it stands for rotate accumulator towards left side through carry. RAL stands for rotate accumulator towards left side through carry. Now let us take the same example. I'll take number 78. The 78 converted in binary format. The number is stored in accumulator. We are shifting it towards left side by one position. As and when you shift it towards left side, one bit will move out. So here the same case, the number 0 has come out and something has to be stored at the right hand side, right? Now what happens is, here the connection is made like this. The number will move out, the bit is going to move out of this particular register, and the content whatever is there in the carry is going to come and store at the right hand side. See, this is the difference in RAL and RLC. RLC stands for rotate accumulator towards left side. RAL stands for rotate accumulator towards left side through carry. As and when you move it through carry, What happens is the content of carry, it goes and stores at this right hand side, the last position, and the content of the bit which is present at the left hand side, it goes to the carry and it stores. So this is about the two instructions RLC and RAL. Rotate accumulator towards left side, and one more is rotate accumulator towards left side through carry. Now let us switch over to the next part, right rotation. Now we are shifting the number towards right side by one position. For that, again there are two instructions. So the first instruction is RRC, rotate accumulator towards right side by one position. Now the same example, number 78, the binary equivalent you can find in accumulator, it is stored. Now the carry is at the right hand side. What we are doing, we are applying instruction RRC, rotate accumulator towards right side by one position. So what happens, the content of accumulator is going to shift towards right side by one position. It is not towards left side. The content of accumulator is going to shift towards right side by one position, right? So the content of accumulator is shifting towards right side by one position. Yes, it has already moved out of the register. The rightmost bit has moved out and currently it is stored in carry. Now what happens, the same conditions of left instruction, whatever the number has come out, the bit has come out, the same bit it goes and stores at the left hand side. See, during left operation, right part will be vacant. Now we are performing rotation towards right side, automatically the leftmost bit will be vacant, so there the number goes and stores. See, on screen you are finding the bit 0 has come out and the same bit has stored in the left hand position. This is RRC. The last instruction, RAR, rotate accumulator towards right side through carry. The way we have moved bits towards left side through carry, similarly here we are moving the bits towards right side through carry. The content of accumulator is already shifted towards right side by one position. So left side, the last block is vacant. Something has to be kept there because we need one complete register. So what happens here, connection is made in this particular style. The content of accumulator has moved out to the carry and the content of carry has moved out, and the content of carry has moved towards left side, and the number 0, the bit 0 has stored towards this left side. This about the fourth instruction, RAR, rotate accumulator towards right side through carry. So in this session we have discussed four instructions which are divided into two parts, left rotation and right rotation. Under left rotation we have discussed two instructions, rotate accumulator towards left and rotate accumulator towards left through carry. And in right rotation category we have discussed two more instructions, rotate accumulator towards right side and rotate accumulator towards right side through carry and without carry. So hope you have understood this rotate instructions. Two types, left rotation, right rotation, and in both the types we have got two subcategories. So this is the concept of rotation. There are different applications, for example, to generate the pulse waveform, and there are many more examples. To implement this kind of programs, what we need these rotate instructions. So these four instructions has to be studied. Good time, take care, thank you.